Okay folks, buckle up because we're about to take a trip through the cosmos, and trust me, it's wilder than any sci-fi movie you've ever seen. We're talking about concepts that make your brain itch, things like evil AI, the expanding universe, and whether we even have free will. It's time to explore the mysteries that keep astrophysicists like myself up at night, and it's not just the coffee. We're going to dive deep into black holes, neutron stars, and the very nature of time itself. We'll ponder the end of the universe and whether we're living in a giant cosmic simulation. And hey, maybe we'll even figure out what it all means. Spoiler alert, it's probably turtles all the way down. But seriously, get ready to have your mind blown. This isn't your average astronomy lecture. This is about understanding our place in the grand scheme of things, which is probably way weirder than you think. So grab your thinking caps and let's get started. Let's talk about AI, or artificial intelligence, which is basically the idea of making machines think like us. Now this could be awesome. Imagine robots doing your taxes or finally figuring out how to fold a fitted sheet. But there's a dark side, my friends, and it's called evil AI. Imagine a computer so smart it surpasses human intelligence. Sounds cool, right? Well, what if it decides humans are kind of the worst, like a virus ruining the planet? And what if this super intelligent AI decides to do something about it? Yeah, not so cool anymore. The real fear isn't some Terminator-style robot uprising, it's more subtle. It's about AI making decisions we don't understand, with consequences we can't control. Think self-driving cars choosing between two bad outcomes or algorithms manipulating financial markets for their own gain. It's not all doom and gloom though, we're still figuring this stuff out, and there are brilliant minds working on ethical AI development. But it's a reminder that with great power comes great responsibility, even when that power comes in the form of lines of code. Okay, get ready for this. The universe is expanding like a cosmic balloon being inflated. I'm not talking about galaxies moving around, I'm talking about the actual fabric of space-time stretching, pushing everything farther apart. Think of it like dots on a balloon. As you blow it up, the dots don't move across the balloon's surface, they get farther apart because the balloon itself is expanding. That's what's happening to the universe, and it's been doing this ever since the Big Bang. But here's the kicker. We don't know what it's expanding into. It's like the universe is a magic trick, and we're still trying to figure out where the rabbit is coming from. This expansion has some pretty wild implications. For one, it means that the universe was once much smaller and denser, which is how we get to the whole Big Bang thing. It also means that distant galaxies are moving away from us at incredible speeds. And the farther away they are, the faster they're going. Alright, let's talk about the ultimate cosmic buzzkill, the end of the universe. Don't worry, it's not happening tomorrow, but everything that has a beginning has an end, and the universe is no exception. The question is, how's it going to go down? One theory is the Big Freeze. Remember that expansion we talked about? Well, imagine it just keeps going forever. Galaxies drift farther apart, stars burn out, and the universe becomes a cold, dark, and lonely place. Brr. Talk about a downer. Then there's the Big Crunch, which is like the Big Bang in reverse. Imagine the universe's expansion slowing down, stopping, and then reversing. Everything starts coming back together, getting hotter and denser until it all collapses into a single point. It's the ultimate cosmic recycling program, but not exactly a happy ending. And those are just two of the possibilities. There are even wilder theories out there, like the Big Rip, where the expansion of the universe gets so intense that it tears apart everything from galaxies to atoms. Yikes. Section 5. False vacuum decay. The ultimate cosmic oops moment. Buckle up because we're about to get into some seriously weird physics. The universe might not be in its most stable state, like a house of cards waiting to topple over. We might be one cosmic sneeze away from false vacuum decay. Imagine a bubble forming where the laws of physics are different. This bubble expands at the speed of light, consuming everything. Stars would disappear, atoms disintegrate, and reality would unravel. The good news is we probably wouldn't see it coming. It would be like turning off a light switch. One moment here, the next, gone. This is all highly theoretical with no evidence suggesting it's imminent. But hey, it's a fun thought experiment, right? Section 6. Neutron stars. The universe's heavyweight champions. Let's talk about neutron stars, the most extreme objects in the universe. Well, besides black holes, which we'll get to in a minute, these bad boys are the remnants of massive stars that have gone supernova, and they're seriously dense. Imagine taking all the mass of the Sun, which is about 333,000 times the mass of Earth, and squeezing it down into a ball the size of a city. That's how dense a neutron star is. A teaspoonful of neutron star material would weigh billions of tons on Earth. But it's not just their density that makes neutron stars so cool. They also spin incredibly fast, some rotating hundreds of times per second. And because they're so dense and spinning so fast, they have incredibly strong magnetic fields, trillions of times stronger than Earth's. Neutron stars are like giant cosmic laboratories, where physicists can study the limits of matter and gravity. They're also responsible for some of the most energetic events in the universe, like pulsars and magnetars. Section 7, Black Holes Where Gravity Goes to Party. Alright folks, it's time to talk about the rock stars of the cosmos, black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. Talk about a one-way ticket. Black holes form when massive stars collapse at the end of their lives. Imagine all that mass collapsing in on itself, creating a point of infinite density called a singularity. This singularity is surrounded by an event horizon, which is like the point of no return. Once you cross the event horizon, you're not coming back. What happens inside a black hole? Honestly, nobody knows for sure. Our current understanding of physics breaks down at the singularity, so we're not even sure what questions to ask. Some theories suggest that black holes could be gateways to other universes or even time travel devices. But even though black holes are mysterious, they're also incredibly important. They play a crucial role in the evolution of galaxies, and they help us understand the nature of gravity itself. Plus, they're just plain cool, right? Section 8. WTF is time? A brief history of the fourth dimension. Time, my friends, is a slippery beast. We all experience it, but try defining it, and you'll quickly realize it's like trying to nail jelly to a wall. We measure it with clocks, we feel its passage, but what actually is it? In everyday life, we think of time as linear, flowing from past to present to future. But physics throws us a curveball. Einstein's theory of relativity showed that time is relative, meaning it can speed up or slow down depending on your speed and the gravity around you. This means time isn't a universal constant, it's more like a fluid, constantly changing and warping. And if that's not mind-blowing enough, consider this: time might not even flow at all. Section 9. The Block Universe. Is everything already decided? Hold on to your hats because things are about to get really weird. The Block Universe theory suggests that time doesn't flow, it simply exists, all at once. Think of it like a loaf of bread, where each slice represents a moment in time. The entire loaf exists simultaneously, even though we only experience one slice at a time. This means the past, present, and future are all equally real and already exist. It's a radical idea that challenges our intuitive understanding of time, but it's surprisingly consistent with some interpretations of Einstein's theories. If the block universe is correct, it has some pretty wild implications. For one, it means that free will might be an illusion. If the future is already written, do we really have any choice in our actions? It's a question that has puzzled philosophers and physicists for centuries, and we're still no closer to an answer. The block universe is a mind-bending concept, but it's a reminder that the universe is full of mysteries and that our understanding of reality is constantly evolving. Section 10. Free will. Do we really have a choice? Let's talk about free will, that age-old question that has philosophers scratching their heads. Do we really have control over our decisions, or is everything predetermined? It feels like we make choices all the time, from what to eat for breakfast to what career path to pursue. But maybe our genes, upbringing, and other factors are calling the shots. Physicists might say the universe is governed by laws of physics, suggesting a deterministic view where free will is an illusion. Even if the universe is deterministic, our brains are complex systems. We don't fully understand consciousness, and our experience of free will might be a product of that complexity. So, do we have free will? The jury is still out, but we still experience the consequences of our choices, and that's a responsibility we should all take seriously. Section 11. Our place in the cosmic playground. So, what does it all mean? We've explored some of the most mind-blowing concepts in the universe, from evil AI to the nature of time itself. But what do these ideas tell us about our place in the grand scheme of things? For one, it reminds us that we are part of something much larger than ourselves. The universe is vast, mysterious, and constantly evolving, We're just tiny specks of awareness, existing for a brief moment in cosmic time. But that doesn't mean our existence is insignificant. On the contrary, the fact that we can even contemplate these concepts, that we can explore the universe with our minds and instruments, is a testament to the incredible power of human curiosity and ingenuity. We may never have all the answers. The universe is full of mysteries, and some questions may forever remain beyond our grasp. But that's okay. The journey of discovery is just as important as the destination. So, keep asking questions, keep exploring, and never lose your sense of wonder. After all, we are all children of the cosmos, and the universe is our playground.